Good morning, students. Welcome to the class of Parallel Computing. I am Anuradha Sharma, Assistant Professor in the Department of Computer Science and Information Technology, Jharkhand Rai University. Welcome all of you in this class. In this semester, I am going to take the class of Parallel Computing. This paper is a 4-credit paper, and let's have a look on the syllabus. Hope you all must be staying safe and healthy at home. Let's look to the syllabus. The whole syllabus is divided into 4 modules. In the first module, we will learn about what is parallel computing and what is the need of parallel computing, the different terminology associated with parallel computing. Also, we will learn about the different application areas of parallel computing. In the second module, we will learn about the different PRAM algorithm, also the model of parallel computing. That it means what will be the architecture of parallel computing. In the third module, we will learn about the different types of parallel computers, that is processor A, processor array, multiprocessor and multi-computers. And in the fourth module, we will learn about some elementary parallel algorithms which is specially designed for the parallel computers. So the whole syllabus is divided into this 4 modules, and in this semester we will cover all these 4 modules. Now let's move to the slides. First of all, I would like to discuss about the serial computing, which one was the traditional one. In serial computing, software has been written for serial computation. In serial computing, a problem is broken down into discrete series of instructions, and then these instructions are executed one after another, or you can say that these instructions are executed sequentially. In serial computing, there is only a single processor. In this processor, we feed the instructions one by one, and then the instructions are getting executed and the output comes. The problem with this computing is that only one instruction may execute at any one moment of time. But when we move to the parallel computing, in parallel computing, we have a multiple number of processors or multiple number of computers. If we talk about multiple number of processor, then that system is known as multiprocessor. And if we have a multi number of computers and all those computers are connected through a network, then it becomes a multi-computer. In parallel computing, we make simultaneous use of multiple computers resources to solve a computational problem. We execute the instruction on multiple CPUs. Here the problem is decomposed into multiple parts that can be solved concurrently. Each part is decomposed into a set of instructions, and then instructions are executed simultaneously on different CPUs. Let's figure out the difference between the serial computing and the parallel computing through this image. This part of the image depicts the serial computing, while this part shows the parallel computing. In serial computing, as I told you, there is only a single processor, and a task is broken down into a different number of instructions. Each instructions are given to the processor one by one. The instructions get executed and then the output comes. But the limitation with the serial computing is that the processor is made up of semiconductor devices. So we can increase the speed up to a limit. If we will increase the workload on this processor, it will get heated, and after some times it will get melt. So we can't increase the workload very much. We have to increase the workload up to a limit. But when we move to a parallel computing, we have a number of processors. For example, here we have two processors, and if the same task is executed, we will break the task into different set of instructions, and the set of instructions are fed into the different processor. So we have divided the same task, the workload of the same task among the two processors, so the work becomes easy. But a proper coordination is required between both the processor, because if the output of this processor depend upon the output of the first processor, then the result should be come first, so that this processor can use that result. So this coordination requires between the different processors. So these are some challenges with the parallel computing. Later on, I will discuss how to handle these challenges and what we can do to overcome these challenges. Now let's see the another image where I can show you the serial computing and the parallel computing. This picture is serial computing, while this picture shows parallel computing. Why this is a serial computing? Because we are making use of a single processor. Here the problem is decomposed into different set of instructions, and each set of instructions are given to the processor one by one. The instructions get executed and then the output comes. But you can see the picture here. Here a problem is decomposed into different set of instructions, and those set of instructions are given to a different processes. But the beauty of this processor, the beauty of parallel computing is that all the instructions are executed simultaneously. So the same task can be done in a very short period of time. For if we talk about uh, if we talk about the example of a serial computing, let's take the example of a mall where there is only a one person at the counter. So when we go to the counter, that we have to give, the person will get all the clothes, then he will put the money description on the computer, then he will make a bill and put the clothes in the polythene and he will give you. It means the say all the tasks or all the things are done by a single man. But if we take the example of a parallel computing, here at the counterpart there are four-person. In the first person, to the first person we have to give to the bill. After giving the bill, he will ask us to move to the second counter where we have to pay the amount, and at the third counter the packet can be collected. So the things becomes easy and the load does not come to a single person. Or if we talk about in sense of computer, the workload does not come to a single processor. Now let's move to the another slide. Then you must be thinking about if the serial computation or the single processor was working already good, then what was the need of parallel computing, or why we need a powerful computers? There are various fields where we make use of a powerful computers, and these fields are science, engineering, business, defense, and we will see where we can use these powerful computers. If we come to the field of science, we have to record the global climate change, astrophysical modeling. In biology, we have to talk about genomics, protein folding, drug design, computational chemistry, computational material science. These all require a huge amount of computation. And in order to perform this computation fast, we require a